You guys, so you can do this on a Google Doc, or you can do this on, if you print this out, you can do it on that, or on a separate sheet of paper, you can work through it. Okay. So Newton's second law, what we talked about when we did in class. Let me just put the autofocus lock here. Bang. All right. So it states that the acceleration produced by a net force of an object is directly proportional to the magnitude of the force. It is in the same direction, as the net force, inversely proportional to the body. So that means whenever an alteration is made to the net force, the same will change the acceleration. Double, triple, quadruple the net force, the acceleration will do the same. On the other hand, whatever change is made to the mass, the opposite or inverse will occur with the acceleration. You double, triple, or quadruple the mass, the acceleration will be 1/2, 1/3, or 1/4 of its original value. If both of them are doubled, then the net force will remain unchanged. So one, how is acceleration and net force, or how is acceleration related to net force and mass? That's just going to wind up being kind of up here. Give me this thing. Give me a line. Click. Give me a line. All right. So yeah, all the stuff that you're going to need to answer number 1 will be right in there. Very, very simple. Now, the next one, a girl pulls in a wagon. Now, mass of the wagon. If you're not sure what the units are for these guys, I'm just going to kind of put it over here on the side. Mass is going to be measured in kg. Force, or net force, is measured in newtons, capital N. And acceleration is in meters per second squared. So when you see those things, you'll know what variable that they're talking about. So a girl pulls a wagon, 17 kilograms with a force of 27 newtons. What is the wagon's acceleration? So they want the acceleration. They want A. How do I do that? Well, if I'm not sure, if I cover A up in the triangle, cover it up, A would equal F net divided by M. I'm just going to write out the equation first. F net over M. All right, cool. What is everybody? Well, M was 17 kilograms, and the F net was 27 newtons. So now I can just plug these numbers in and calculate the answer. F net was 27, so we're going to have 27 over 17. Comes out to be 1.5888 repeating, so, or not repeating, but and change. If I want 2 decimals, I would call this 1.59. Now, what is the unit for acceleration? Dang, I forgot. Well, if you write it here, you'll be good. Or you can use context clues, and it's also somewhere around here on the rest of your assignment. So a force of 25 newtons accelerates a mass of 25 kilograms at a rate of 1 meters per second squared. The acceleration of a mass of 50 kilograms acted on by a force of 50 newtons. Well, what is the acceleration going to do? So, I mean, this you guys could probably just figure out common sensely, or I'm just going to kind of show you again how the one's equation works, or you can do it. There's a couple different ways. Common sense, all right. If you show the acceleration is as force over mass, so you did 25 over 25 and you got 1. Cool. You can do it this way. So what is the next one going to be? Well, it's 50 newtons over 50 kilograms. 50 over 50 is still 1. So the acceleration would remain unchanged. It would be the same, 1 meters per second squared. But what if the force acting on a cart doubles? Then what happens to the acceleration? Well, if you read up top, the acceleration of an object is going to be directly proportional to the force. So what happens to the force is going to happen to the acceleration. But if it required you to give a specific number or something along those lines, what you can do is refer to this kind of as, I'm just going to kind of do this. So this stuff here is going to go to number 4. Take this equation and just call everybody a 1. So the acceleration of an object, 1. The net force, Jesus, not a 1. The 1 and the mass as a 1. So whatever everything wasn't originally, we just call it a 1. Doesn't matter. So for these proportionality problems where they don't give you a number, they just say like something doubles, something triples, something gets cut in half, you can manipulate the variables you need depending upon what they did. So we can essentially just give them numbers. So if the force acting on the cart doubles, so F net would be the top guy here. So if that doubled, we would say it is a 2 instead of a 1. They didn't tell us anything about a mass, so the mass, which is on bottom here, stays a 1. And then you can just solve this out to figure out what happens to the acceleration. This one's pretty simple. 2 divided by 1 is going to be 2. So it'd be 2 times the acceleration. Or it doubles in this case. So the force acting on the cart doubles. What happens to the acceleration? You can just write it out. Bless you. The acceleration doubles. Now, we have a number 5 here. Suppose a cart is being moved by a force. If suddenly a load is dumped into the cart so that the cart's mass doubles, what happens to the cart's acceleration? So a load is just essentially any heavy object, essentially. Be a thing of dirt, soil, sand, water, whatever. So if that change is increased so that the mass doubles, what happens to the cart's acceleration? Well, if I'm not sure and I don't feel like reading up here, which the answer is in there, you can just, again, set everybody as a 1. Acceleration, force, mass. All right, so if you want to show A is F net over M, keep everybody as a 1. If we double the mass here is on bottom. So we're going to cause that to become a 2. In the problem, they say nothing about force, so that remains unchanged. So this, all right, we're just kind of changing and figuring out. So 1 over 2 is just going to be 1/2 of the acceleration. So the acceleration is going to be cut in half. Pretty straightforward. Number 6, they say a car has a mass of 1357 kg and accelerates at 4.3 meters per second squared. What is the net force on the car? F net, all right, is your equation, and you have your 2 different variables. So I'd write F net is your question mark. The equation for F net is mass times acceleration. You have mass, you have acceleration. You guys can do the math there to figure that out. Number 7, you pull horizontally on a 35 kilogram crate with a force of 470 newtons, and then there is a friction force on the crate. And that friction force on the crate is 200 newtons. What is the acceleration of the crate? So for this one, you guys are going to need to draw out a free body diagram. So you're going to have a box. So if you're pulling the force, all right, if the force is being pulled with 470 newtons. All right, that's the pull force. It is encountering 200 newtons worth of friction. Friction is little f. So friction is 200 newtons. Remember, in this equation, we need the net force. Net force is only one thing. So by kind of drawing this out, if you have forces in opposite directions, to get the net force, you're going to wind up subtracting them. So what would the net force be here? 470 minus 200. And that is going to give us 270 newtons. Okay. So they wanted acceleration. A is your question mark. And from the triangle, A is the F net over M. And we have the net force of 270 over 35 kilograms. And that is going to kick out an answer of 7.714 and change. And for keep it as a round to 2 decimals, we'll call it 7.71. What is the unit for acceleration? Meters per second squared. In the next one, you have cart A that has a mass and a force. Figure out what its acceleration is. Cart B, you have a mass and a force. Figure out what the acceleration is. And then just determine which one's bigger. So you have to show your work for it. Both of these you're solving for, all right, the acceleration. So for cart A, acceleration is net force over M. Find that one. Part B, same thing. Acceleration is F net over mass. So figure out, calculate them, plug the numbers in, get your answer. Okay, this last piece. Let's move this up here. Where's my? Yep. Excuse me, Mr. Mouse. There you are. Okay. So this last piece in this diagram, there's a couple different things going on here. You have the mass of this whole system. So we have to figure out in this whole thing the acceleration of this car. So when you see a problem that is done like this, the acceleration is going to be your net force divided by the mass. But specifically for this type of problem, F net is the weight of the hanging mass. And the mass is the mass of everything. Now, weight, there's an equation for weight. It was in the notes that we kind of had gone over before. It's pretty much the same equation as this. Weight is a force, except the acceleration is going to be gravity. So W is weight. It's measured in newtons. Mass measured in kilograms. And then gravity, little g, is in meters per second squared. So if you notice, these guys here are all in mass. They're given a mass here. The cart and the 2 blocks. So what is the total mass of these carts? 4, right? The 2 plus the 1, 3 plus the cart. So there's 4 here. There's 4 kilograms worth of mass in this situation. But our equation says we need the mass of everything. That means the cart, all the blocks on it, and the mass of this guy. But it's only given to us in newtons. They said a 15 Newton weight accelerates. So we have to figure out what the mass is. Well, if I go over here real quick, mass is equal to weight divided by gravity. So the weight of this object is 15 newtons. Now, Earth's gravity, the negative 9.8, we're using 10 in this situation. We're going to just leave out the negative for now because masses cannot be negative. If we really wanted to, this would be negative 10. The weight vector would be negative 15 because it would be down. But we're just going to leave it simple here. 15 over 10. You plug that in, and you're going to get a mass here of 1.5 kilograms. So this dude here, its mass is equal to 1.5 kg. So if I just zoom out for a second, so we can kind of see here. The acceleration is the net force. It's the weight of the hanging mass, which is given to us here as 15 newtons. And the mass of everything, which is the mass of the cart, the blocks in the cart, plus the mass of the hanging block itself. So it's the 4 kilograms plus the 1.5. So 4 plus 1.5 is going to give us 5.5 kilograms. So when you divide that out, we're going to get 2.7272 repeating. So we're going to call it, if we round it to 2 decimals, 2.73 meters per second squared as our final answer, our acceleration. All right, so that would be, guys, how you're going to do the homework. See ya.